Alright, hi there. This is Dr. Thomas, and in this presentation I want to talk to you about relations and functions. It says a relation is a set of ordered pairs. So for example, we have this relation here. What is the domain? What is the range? The domain is the set of all x values in green here. But you want to put it in order from smallest to largest. And the range is the set of all y values in blue here. And you want to put those numbers in numerical order as well. So that's how you find the domain and range of a relation. Now let's look at this set of all x's and set of all y's. Notice that 1 is assigned to 6 here, 2 to 2, 3 to 4, 4 to 8, 5 to 10. This relation can be written as 1, 6, 2, 2, 3, 4, 4, 8, and 5, 10, because the green egg represents the x value and the blue egg represents the y value. Therefore, we can write it as a set of ordered pair. What is a function? A function f from set A to set B is a rule of correspondence that assigns to each element x in the set A exactly one element y in the set B. Whew, what did that say? Well, all it really means is the x value can only be assigned to one y. So 1 is assigned to 4 here, 4 to 8, 2 to 2, 5 to 6, 3 to 10. All x's are assigned. No x has more than one y. Therefore, this is a function. It meets our condition. Let's look at another relation. 1 goes to 4, 4 goes to 4, 2 goes to 4, 5 goes to 4, 3 goes to 4. Is this a all x's are assigned. No x has more than one y. Therefore, it is a function. It meets our conditions. The second condition says each x can have only one y, but it can be the same y as another x. Let's look at this example. A good example that you can relate to is students in our math class, for example. Let's say the students in our math class this semester are set A. The grade they earned out of the class is set B. Each student must be assigned a grade, and it can only be assigned one grade, but more than one student can get the same grade. Alright, let's say that student 1 gets an 82, student 2 gets a 91, student 3 gets a 99, student 4 gets a 79, student 5 gets a 40. Is anything wrong with that? No, until student 2 also gets a 40 out of the class. One student cannot get a 40 and a 91. So is the relation shown above a function? No. Why not? Each student must be assigned a grade and can only be assigned one grade out of the class. Student 2 was assigned both 40 and 91. Let's check this relation out to determine if it is a function. It is not. 3 didn't get assigned to anything. Compared to our example, a student in maths must receive a grade. A student in mathematics must receive a grade. So this is not a function. Check this relation out to determine if it's a function. What do you think? This is fine. Each student gets only one grade, More than one can get an A, and I don't have to give any D's. Hopefully I don't give any D's. So all Y's don't need to be used. This is a function. Let's talk about function notation. We commonly call functions by letters. Because function starts with F, it is commonly used the commonly used letter to refer to functions. The left hand side of this equation is the function notation. It does not mean F times X. Okay? It means the function is named F of X, and X is the variable that we're using. Alright, remember, F of X tells us what is on the right hand side. It is not something you work out. It's really the same thing as Y. So we have a function called F that has the variable X in it. Using function notation, we could then ask the following. Find F of 2. So what do we do with this 2? All we have to do is replace all of the X's with a 2. So notice how each X is replaced with 2 here. And then you can simplify. You must follow the rules of order of operations to simplify. So it'll be 2 times 4 minus 3 times 2 plus 6, which will give us 8. So F of 2 equals 8. Now what I want you to do is pause the video and find out what's F of negative 2 if F of X equals 2x squared minus 3x plus 6. It is 20. What about F of K? Even though K is not a number, we still replace every X with what's inside the parenthesis here. So what's inside this parenthesis K? So you replace every X with a K, and your answer turns out to be 2k squared minus 3k plus 6. Now even if you had 2k inside of your parentheses, you can replace all your x's with a 2k. Like so. Then you would get 2k squared would be 4k squared, for example. You'll get 8k squared minus 6k plus 6, which is 8k squared minus 6k plus 6. We also need to understand the concept of domain. For the functions we will be dealing with, there are 2 illegals. You can't divide by 0, meaning denominator of a fraction can't be 0, and also you can't take the square root or even root of a negative number. So when you are asked to find a domain, you can use any value for x as long as the value won't create an illegal situation. So for example, let's find a domain of f of x equals 2x minus 1. Are we allowed to substitute any x into this function? Yes, since no matter what value you choose for x, you won't be divided by 0 or square rooting a negative number. You can use anything you want, so we say the answer is all real numbers. Now we also use this notation for all real numbers. So if you see this notation that looks like an R, it also represents all real numbers. Alright, what about g of x? Can we substitute any x value into these x's? If you choose x equals 2, the denominator will be 2 minus 2. So we can't use the number 2. So the answer for the domain is all real numbers except 2, or all real numbers x such that x cannot equal 2. Let's note that there's nothing wrong with the top equaling 0. We are only concerned about the denominator equaling 0. What about the domain of the square root of x minus 4? You have to be careful what x's we use so that the second illegal of square rooting a negative doesn't happen. This means the stuff under the square root must be greater than or equal to 0. So everything that's under the square root, we can set it greater than or equal to 0. Let's do that. So let's set x minus 4 greater than or equal to 0 and solve for x here. If we add 4 to both sides, we get x is greater than or equal to 4. So this is our domain. The answer is all real numbers such that x has to be greater than or equal to 4. Summary of how to find a domain. Look for any fractions or square roots that could cause one of the two illegals to happen. If there aren't any, then the domain is all real numbers. So this is important. If you do not encounter one of those two illegals, the answer is all real numbers. If there are fractions, figure out what values would make the bottom equal 0. And those are the values you can't use. The answer would be all real numbers x such that x cannot equal to whatever that value was. If there is a square root, the stuff under the square root cannot be negative, so set the stuff greater than or equal to 0 and solve. The answer would be all real numbers x such that x has to be greater than or equal to this number. Of course, your variable doesn't have to be x. It can be whatever variable that's in the problem. I have to show you one last thing. Okay, so let's say we had some graph. Some type of graph here. Like so. And you were asked, what is, and this is the graph of f of x. Okay. And I say, what is f of 0? What this is saying is when x is 0, so this is graph of f of x. Okay, this is y also. When x is 0, what it's saying is, what is y? When x is 0, what is y? So 0 is here. What is y? Y is whatever point that's on this graph. So let's say each of these little squares is by 1. So this is 1 here, this is 2, and this is 3. So when x is 0, y is 3. So that's the answer. Let's say I ask you what is f of -1. So what it's saying is when x is -1, what is y? So this is -1 here. We meet this graph. The graph is right here. What is this on the y-axis? This is the y-axis. This is the x-axis. So when x is -1, what is y? It must be 4. One more. I want you to tell me what is f of 5. Now let's do f of 4. What is f of 4? Question mark. you figure out what f of 4 is. Alright, so this is 1, 2, 3, 4 right here. It must be this number, which corresponds to 5 on the y. So the answer is 5. Okay? So this concludes the video on functions, and I hope that it helps you understand the questions that are on the exam.